Namaste to one and all. This is Madhuri at Science at Your Tips. Welcome back to another session of hybridization. Here we will discuss about sp2 hybridation. So this hybridization concept, which is given by Linus Pauling, is there to explain the energy of the orbitals, energy of the shape of the molecule, right? So sp2 hybridization we are going to discuss here, and this also we are going to discuss based on carbon compounds, right? So let me take here one compound whose formula is C2H4. So if it is C2H4, how to give the name of this? Already before videos you can check nomenclature of organic compounds. In that you can understand how to write the name of this. As two carbons are there, it we have to give the name. And also if you see this compound formula C2H4, you can say this is related to the general formula of CnH2n. So based on this general formula, we can say it belongs to alkenes. So we can give the name as ethene. Ethene, a UPSC name according to International Union of Pure and Applied Chemistry, or otherwise can give the common name as ethylene. So in this ethylene, how this hybridization is formed, and also how these atomic orbitals of hydrogen are going to overlap with the carbon's hybrid orbitals, that all we'll see. So let us take carbon first. Carbon atomic number 6. So we can write configuration as 1s2, 2s2, 2p2, right? So it will go into excited state. The reason already it is explained in sp3 hybridization, just check it that. So one electron will jump from 2s to 2p. So excited state carbon electronic configuration we can write 1s2, 2s1, 2p3. Electron present in 1s is not going to participate because it is a core electron. That is nothing but shell. Electrons present in the inner shell. So inner shell electrons are not going to participate in this case. So we are taking only 2s and 2p orbitals. So in 2s we have only one electron that we can show in this square form. Then after that, p orbitals electrons we are going to write 1 in each orbital according to Hund's rule, right? After that, this here we have carbon, 1 electron is present in 2s, 3 unpaired electrons are present in 2p. So altogether 4 unpaired electrons are there. Now what happens? One s orbital and 2 p orbitals are going to overlap with each other, intermix with each other, and one orbital will remain like that. That is nothing but pure orbital. So what happens here? One s orbital which is in spherical form and 2 p orbitals which are present in dumbbell shapes, px and also py, are going to intermix with each other. So here we are going to get hybrid orbitals. 3 sp2 hybrid orbitals are formed here. 3 sp2 hybrid orbitals. How many atomic orbitals will intermix? That many number of hybrid orbitals are formed. So as 3 orbitals are intermixing, 3 hybrid orbitals are formed here. So 3 hybrid orbitals are formed here, and then what happens? Here actually we have 2 carbons in this C2H4, that is ethene or ethylene. So 2 carbons will undergo the hybridization, and total together we are going to get 6 hybrid orbitals. So in those 6 hybrid orbitals, what happens? sp2 orbital of one carbon will overlap with the sp2 orbital of another carbon first. So here I am going to write that structure. One sp2 hybrid orbital of carbon overlaps with the sp2 hybrid orbital of another carbon. Remaining hybrid orbitals are present here only. Remaining hybrid orbitals are present like this, and along with that one more pure orbital also is there, no? So that one more pure orbital we are going to show here like this. So when you are going to show this to the children, you can use the different colors of chalk or different colors of the markers so that they can understand very easily. So just here I am drawing somewhat dark for this pure orbital. You can use different colors. So dark color we have drawn for pure orbital. So here what happened up to now, sp2 orbital of one carbon has overlapped with the sp2 hybrid orbital of another carbon. So one sigma bond is formed. Then what happens here? Between carbon and hydrogen also bonding should be there. How many hydrogens are there here total together? 4 hydrogens are there. In each hydrogen, 1 electron is present, and that 1 electron also is present in s orbital, right? So what happens here, along with that s orbitals, directly I am showing the overlap instead of showing the s orbitals separately. So those s orbitals of hydrogen will overlap with the hybrid orbitals of carbon. So here 2 and also here 2 will overlap. And after that what happens? Between the pure orbitals, here some sidewise overlap is there. Sidewise. One orbital is present here, another orbital is present here, just sidewise overlap is there. They are not going to overlap end on end, just sidewise overlap is there. So that you can show here how we are going to get both the hands, if you are putting together, how the structure is going to get. Like that only we are going to get the bond also here. This bond can be called as pi bond. Pi shape also almost like this. So pi bond is going to form because of the sidewise overlap of the carbon atoms pure orbitals. So between these pure orbitals again sidewise overlap is there, pi bond is formed. So here how many bonds total together are present in this? One sigma bond between sp2 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 of carbon and sp2 of another carbon. So sp2 sp2 bond, that is sigma bond is there. Next, 4 sigma bonds are formed between sp2 hybrid orbital of carbon and s orbital of hydrogen. So here between sp2 hybrid orbital and s orbital of hydrogen, 4 sigma bonds are formed. Along with that, one more bond also is there. What is that? One pi bond is there. Between which orbitals this pi bond is formed? Between pure orbitals. What are those pure orbitals? 2p orbitals, which is left here. This bond is, this orbital is known as a pure orbital. So between that also one bond is formed there. This bond. So that is how you can say between P and P, whatever the overlap is taking place, that can be called as a pi bond because of sidewise overlap of the pure orbitals it is formed. So altogether how many bonds we are getting? 4 plus 1, 5 plus 1, 6 bonds. So once you will check whether 6 bonds are there or not, just by seeing the structure, carbon to carbon, one double bond, one sigma and one pi, one sigma and one pi, and carbon to hydrogen again, sigma bonds are there. Now once we will count the number of bonds, 1, 2, 3, 4, 5, 6. So here also 6. 4 plus 1 is 5 plus 1. Total together here we got 6 bonds. In that 5 sigma and 1 pi bond. 5 sigma and 1 pi bond. Altogether we got here 6 bonds. So this is a structure of ethylene. We can explain sp2 hybridization very easily with the help of ethylene molecule. Thank you.